Okay, good morning, good afternoon, good evening. This is Mike from Unknown Tech, and welcome to the episode 19 of the Architect Podcast. I appreciate you all joining. Today is Saturday, February 28th. We're almost there to spring, thank God, and it's 11 a.m. So I know it's a big ask to ask for people to join the podcast um, on a Saturday, so I appreciate it. And again, let me just put up this. I always put this up here, but I actually stream this to two platforms. I stream this to LinkedIn and I stream it to YouTube. And it seems that YouTube has a better quality stream and you can interact with chat. So if you have questions or things that you want to ask or interact with folks in chat, you should go over to the YouTube channel. And I have that linked here, and I'll keep this up for a few minutes as we set up what today's session is going to be about. So I know it's been a few weeks since I've had a podcast, so I appreciate your patience. Like as always, life is busy, right? And I've been traveling. I just got back from our Global Tech Summit at Nutanix up in Orlando. So that was a great week of a lot of content and just a lot of exciting things on the roadmap coming from Nutanix. Um, it just amazes me how far this company has come from an innovation perspective and how small we are. And that's what's crazy. I look at other companies that have grown, like VMware and Red Hat, and they've been acquired by huge companies, IBM with Red Hat, Broadcom with VMware. And, here's Nutanix, right, chugging along, and the innovation is just amazing. The engineering teams are working very hard. Of course, they're AI assisted as well. I mean, who isn't AI assisted today? And I know probably everybody's getting sick and tired of talking about AI, but you know what? I'm sorry, it's here and it's here to stay. It's not going anywhere. It's just going to expand. It's going to expand in our personal life, and it's going to expand in the workplace, and it's going to expand into pretty much everything that we do moving forward. So we have to embrace it. We have to use it the right ways. And I think, I just talked a little bit about one of the things I was traveling for. I went to an event in New York City with some of the top leadership in the large financials in large companies, enterprise and globals in New York. Um, and it was a great event, right? It was very interactive, and it just was very interactive, and there was a lot of engagement. I was only supposed to speak for 20 minutes, and then we had tables set up to have interaction amongst the peers. I think there's a lot of value in that too, right? When you go to these events, and a lot of these folks go to these events, they want to talk to their other peers in the organizations to see what they're doing and share ideas, etc. And what ended up happening is I actually stood up and took Q&A for 2.5 hours. And so it was very interactive. And, three big themes came out of that. And I'll just share this with you um, because I think it's very important. The first is that companies want to get to revenue generating AI, not just process savings, staff augmentation AI. Okay. And so how do companies get there, right? Well, they get there through an iterative journey, right? And not a lot of people hate the word journey, but that's what it is. And what I mean by iterative journey is you are starting with quick wins, right? Because quick wins show value, and that value can then be reinvested back into your AI solutions, your AI journey, as you get to more revenue generating AI, right? So I think what I'm seeing play out in a lot of the enterprise is some of it is companies seeing a lot of different art of the possible demos. And by the way, I love art of the possible demos as long as it's relevant to the customer you're talking to. Because art of the possible demo should not just be about, um, these grandiose ideas of, oh, what if, right? I mean, that's important to get people thinking. But art of the possible demo should also be about what customers are trying to actually solve for, right? And what is possible to do that, and what can we streamline? And so I go back to the very foundation of what enterprise companies should be looking at for AI use cases. And it's the boring, mundane stuff. It's the back office stuff. It's the process innovation, right? Next to staff augmentation, next to internal developer co-pilot, right? Next, those things, right? Customer service. Like those are the things that are going to get you to quick wins to show real value back to the CX level in the organization, right? And I think, you know, it's hard to it's I'm not saying it's easy to do, but what's harder to accomplish is having people come in and say, we're going to show you, wow you with this demo, right, that solves for this grandiose thing, and it takes forever to get there if you even get there. And what we're finding is, as people focus on these bigger ideas and bigger wishes, right, where they want to get to, that's when there's a lot of friction, right? And so the formula that I'm constantly reiterating about getting to revenue generating AI is business clarity, number one thing. Okay, meaning what is the value that I'm going to get out of this process augmentation or this replacement or whatever, right? What's the value? And it has to be a real value. It can't be, oh, we're going to simplify this process. Oh, I can remove, I can replace 5 of my staff and they can do other things, right? I need an end state value. What does that result in cost, in revenue generation, in savings, in real dollars, right? And that's what you have to get to. That's what I'm talking about with business clarity, right? Times a data foundation. And what I mean by data foundation is a foundational information lifecycle management that gives you like the ability to integrate all of your, not all of your data, the data that you want to use for AI, whether it's structured or unstructured, running on the right tier and curated for AI. And so what I mean by that is, um, you know, storage, right? You have storage and you have data services, right? And the concept is, okay, I need to understand, first of all, I need to classify my data and understand what my data is and where it is. That's the very first thing. Then I need to make sure it's running on the right storage platform, right? The protocol, et cetera, whether that's, block storage or unstructured data or structured data, excuse me, or cache, all right? Cache databases, things like that, like Redis as an example, or vector databases or graph databases. We're going to talk about some of that in upcoming sessions about the difference between vector and graph, and we're seeing like this introduction of graph becoming more popular in different scenarios, right? And I don't want to get off on a tangent there, but that's part of it. And then how do I make sure that data is AI ready? The junk is removed, it's deduped, PII is removed from the data, right? So I don't share data as an example. I don't share customer information or personal identifiable information, right? Um, that it's curated. That's not, there's no bias in the data, right? Like it's not opinionated. It's factual. It's grounded in truth. Okay, the data is factual, etc. It's secure, right? It's governed. It's protected. And then again, how do I make sure that data is AI ready? Is it curated? Is it vectorized, et cetera, right? And ready to be fed into AI. And what I mean by fed into AI, I mean is used against models, agents, et cetera, right? Tooling, those things. And then there's another part of this where there is data that customers, frankly, shouldn't have to move or migrate or move around. And so we want to bring AI to data. And what I mean by that is where the data lives, I can apply AI solution against that current data set. So a simple example of this is if I have a bucket of documents stored in an S3 object store, as an example, right? They're all documents. And I'm a global company. And I need to translate those documents in other languages. Why would I want to move that around to an AI solution when I can bring simply AI to the data and have that be translated where the data lives, right? And so I think that's important. So business clarity times data foundation times agentic infrastructure. And what do I mean by that? So agentic infrastructure is a AI platform that is that has all the requirements, accelerated compute, like all the things that you need, right? The data services, accelerated compute, right? All those foundational things, Kubernetes, right? The containerization, the control plane, the observability, all of those things, right? But in on top of that, before the developer layer, right? Because developers are building AI enabled apps against this AI platform, having a simplified, unified model operations, MCP operations, unified gateways, all of those things to make it very, very easy and simple for AI consumption. Okay. That's what I mean by agentic platform. So business clarity times data foundation times agentic AI platform divided by organizational friction. Okay. And what is organizational friction? We all know what that is: lack of skill sets, lack of revenue, security issues, not finding the right use case. Right, goes back to what I said before about folks wanting to boil the ocean and get to this panacea of AI before looking at back office processes that have been broken for years, right? That take resources and time, money, and waste, right? Divided by friction equals, right, a percentage of revenue attributable to AI. That is the formula for success, right? And I know it's a very high level talk track, and but this is what I start the conversation with. And customers are really keen on getting to revenue generating AI. And by the way, those areas that I talked about in that formula, that's what customers are worried about. They're worried about what use cases is good for AI. What's the clarity around those use cases in revenue, waste, etc.? Where is my data? Is my data sovereign protected, right? What does the agentic AI platform look like, right? Is it hybrid? More than likely, it will be a hybrid solution, right? And where do I need to do private AI versus using a cloud provider, a neo cloud, or some other SaaS offering for AI? I say, I always talk about AI, whatever output comes from AI that provides you value is your intellectual property. Okay. I'm going to say it one more time. The output of AI that's providing value is your intellectual property, is your competitive advantage. Okay. So what that means is that you should really focus on those areas, right, that are providing value, that give you competitive advantage. You should get full control over those things. And in order to do that, you should be looking at on-prem private solutions. Okay. And Nutanix Enterprise AI, this is exactly where we play. Okay. And this is what I'm going to talk about a little bit today. And we're going to get more technical. I know I'm kind of at a very high level right now because I'm going to talk about how we get DGX Spark working with AI to show you the power of the platform, right? One of the things I talk about with Nutanix, with prospects, customers, partners, other folks, is Nutanix's journey really started, right, on an opinionated platform, right? It was an opinionated hyper-converged platform. You ran it on VMware when I started. That's the only option you had, okay? And the goal was threefold, basically: to get applications as close to storage as possible, to remove the storage burden, okay, make it simplify, right, and to make it easy to deploy and consume and operate. Those are the three things, right, that started Nutanix. And by the way, those three things are pervasive in everything we do. Every platform service now that we have, that we've innovated and created, right? All those three components, with the exception of storage is close to the application, right? Because that was really focused on HCI. It's really about the simplicity, of implementation, consumption, operations at scale. That's really what the core foundation of Nutanix is. And it translates into all of our solutions and into the overall platform experience. Okay. And so before I get started on this, I want to just go into really quick. We have three solutions, generally speaking, three solutions. Let's just say three solutions, right? When we acquired a company called com.io, that's our integrated self-service, it's our automation stack, right? That automation stack allowed our customers to target any substrate and to deliver automation against. Okay, so what I mean by that is it was a application automation platform first before it became infrastructure aware. Okay. And so when we bought com.io, you could target, meaning that there was SDKs, right, built in for all cloud vendors, GCP, AWS, Azure, as well as VMware on-prem. Okay. And so because we bought it, obviously we added Nutanix, made it Nutanix a first-class citizen, but you still can target those. And that means that you can consume NCM self-service, which is what this product really is, and I hate talking about products, that's what it is, as a standalone solution. Okay, so that was our first array into that. And we have customers doing that. And I'm working with a customer right now actually doing that. Okay, the first foray into Nutanix is not HCI, it's automation. Okay, the second product that we acquired was NKP, which was formerly D2IQ or Day2IQ, however you want to say it. Okay, Day2IQ was a Kubernetes control plane that provided an opinionated stack to give you production grade Kubernetes platform. Okay, not Kubernetes itself, because we use open source pure upstream Kubernetes. So we're not forking, we're not doing Kubernetes. We're giving you a control plane around pure upstream Kubernetes and an opinionated stack that gives you lifecycle management, automation, and many other things, right, within the solution. This can also be consumed and delivered as a standalone product on any substrate. So I think you know where I'm going with the messaging, right? I think about tooling like Terraform, Ansible, and all those things. And what is the power of those things? The power is not just in what it does. The power is that it decouples from the underlying substrate. Right? It's completely decoupled. That means I can now target any cloud provider, any infrastructure, right, etc. This is where Nutanix is going, right? And you'll have multiple ways of consuming. You can get an opinionated stack, or you can get pieces of a stack that are more open. And that's what customers are asking for, right? This is what I'm talking about: removal of lock-in and flexibility, not choice. Choice is a thorn in our customer side. They don't want to have a list of all these things to choose from. They want a solution to their problem. Okay. And what I mean by flexibility, I mean by the ability to consume our platform in multiple different ways, giving you flexibility. Okay. Now I'm going to focus on Nutanix Enterprise AI today, because that's another solution that can layer on any open source Kubernetes, any infrastructure, right? As long as it's accelerated infrastructure, right? Whether it's CPU acceleration for AI using Intel AMX, or GPU acceleration using AMD Instinct, NVIDIA, etc. Okay. And we just announced a partnership with AMD, which I'm very excited about, to actually build a next gen AI operating environment based on what we've already built, right? Paired with AMD's enterprise innovation with Instinct, frameworks like ROCm, etc. So I think that's going to be a very exciting solution when you see it play out towards the end of this calendar year. So NAI is another platform service, right, that delivers a ton of capability, right? And we just released version 2.6, and I want to just cover some of that when I go into the demo. But before we do that, I want to talk about how, the options of how NAI can be installed. So we can deliver NAI as a full platform. Okay, that's called GPT in a Box version 2. I don't particularly care for the name, to be honest with you, but it's just assume it's a full stack, opinionated stack that provides everything: accelerated compute, block services, unified storage, right? Unstructured data, database as a service, Kubernetes through NKP, lastly, NAI layered on top, right? And then, of course, the control plane to manage all of this, right? And so this is a complete, again, I hate to say out of box platform, right? Or in a box platform, but it's a complete architecture that delivers you a full stack experience. And some customers need that, right? Not just want it, but they need it. And so we deliver it that way. There are other customers that already have infrastructure. They already consume accelerated compute, or they have advanced accelerated compute, right? Where a hypervisor doesn't make sense right now. And we'll talk more about that in another session as we talk about where Nutanix is going from a enterprise AI, operating environment perspective. Okay, but right now, right? So think of like DGX, HGX platforms, right? Purpose built where you layer Kubernetes on top, right? And then, or they have bare metal solutions that they want to leverage, accelerated compute. Okay, and you can deliver an AI bundled with NKP, so you get the Kubernetes layer and you get the AI platform layer. Okay, that's another way to consume it. The last way to consume it is the demo I'm going to show you today is NAI running on any Kubernetes. Okay, and the reason I'm going to show you this is because this is kind of an unsupported. This is kind of a fun thing I did. If you watch my previous content, I actually purchased a DGX Spark, and I know you're probably thinking, "Well, you're rich." No, I sold a lot of stuff to acquire that, and I bought it used. Right, so I saved. I want to say I saved like 600 off the bat for buying it used. It still was brand new, basically, but it was 600 off for buying it used. And then I had a RTX 5090, which I sold for quite a bit of money, $3,000. Right, so that pretty much paid for the DGX Spark. Okay, and so one of the reasons why I bought it too was really not thinking along the same lines as most people use DGX Spark for, but integrating that with Nutanix Enterprise AI. What could that look like, right? And to kind of give you a DGX like experience, right, from a demo perspective. That was kind of the idea. Now, two things. Nutanix Kubernetes platform does not support ARM yet. So the GB10 and the DGX Spark is ARM based, right? It's a Grace Blackwell platform. So Grace being the ARM CPU of 20 cores, right? I think 10 performance cores and 10 efficiency cores. And then the Blackwell portion is the GPU, right? And the GB10 GPU is comparable to an RTX 5070 Ti from a performance perspective, tensor cores, all of that. Okay. Except that the memory bandwidth is a lot less. Okay. And one of the reasons why that is because they use um, low profile DDR5X memory, and it's unified memory. Okay, but the other reason why a DGX Spark is a great lab solution is that it's 128 gigs of unified memory, and that memory can be used for obviously system memory or for GPU tasks. And so one of the things obviously is NKP doesn't support ARM right now. It's coming. It's on the roadmap. It's coming very shortly, actually. And so I had to choose another Kubernetes layer to layer onto the DGX Spark. The other decision I had to make was, do I just create a single node Kubernetes cluster, right? Control plane, right? That can be schedulable for workloads, right? And I shied away from that because I want the DGX Spark to be by itself, be the GPU, right? Right, for my AI workloads. And so what I did was I have a Proxmox server, which is going to be transitioned to a community edition server here in the next month or two. But right now it's running Proxmox, and I have an Ubuntu VM using the same version of Ubuntu for x86. Okay, running on my Proxmox server. That is the control plane for Kubernetes and the NAI control plane. Yeah, I'm looking at the chat. Yeah, I know, Lord. The DGX Spark is $4,700 now. I paid $3,300 for mine, so about $700 off. It was $3,999, $3,999, right? And I got the NVIDIA one because it was 4 TB NVMe. Just to go off on a tangent really quick to address that, You can buy the Asus G10 for the 1 terabyte model for $3,000, and I know it's still expensive. And you can upgrade that to 4 terabyte NVMe. Corsair makes a Gen 5 NVMe small form factor. I can't remember the actual number, 22 something, that you can upgrade and pay a lot less than the NVIDIA DGX Spark. Okay, so again, going back to what I did was I did the control plane on a Proxmox node running Ubuntu, right? And I'm using K3s, right? K3s, right? An x86 variant. And then on the DGX Spark, that already has Ubuntu, has DGX OS on it, which is based on Ubuntu. Okay. And I installed K3s ARM variant on that. And so basically I made a control plane worker node for everything other than AI inferencing. Okay, so all the workloads run on the control plane on Proxmox. That means the observability stack, the NAI control plane, all of that runs on the x86 node, and the NVIDIA DGX Spark that runs the endpoints, right, for AI. And so what I'm going to do here is I'm just going to share my screen here. Just bear with me a second here. Okay, hopefully you guys can see that. Let me just do this really quick. I have to move this down here. Okay, so this is kind of small, so I'm going to just click in here a little bit and just show you. So on the right-hand side, bottom right-hand corner, right, those are the nodes, right? So you see that I have the Spark DC9B. That's my DGX Spark. And then to the right, I have my K3S-CP control plane. It's not just a control plane, again, like I said, it's actually schedulable. So not only is it running the control plane for Kubernetes, but also running all of the control plane for Nutanix Enterprise AI, right? All of pretty much 90% of um, the observability stack, all of that, ingress, load balancing, all of that. Okay, and you can see how this looks here. And this diagram's a little bit off. I actually did this in Python. Um, there's a Python module for creating diagrams. And so I was able to basically, export my configurations and build this in Python. So it's not perfect. I did it this morning, so I didn't spend a ton of time on it. So to the bottom right is my actual physical cluster nodes. Right, again, one of them is a VM running in Proxmox, the K3SCP, and then one of them is a physical DGX Spark. Okay. And then if you go up here to the left, there are specific things that I've built within the platform, right, that are required and some not required, but I wanted to have. Okay, so the first thing is I'm just going to go through the requirements, right? So obviously I wanted to have some sort of certificate management, right? So I installed Cert Manager, and that basically handles the SSL, right, for my ingress, right, for Envoy Gateway. Okay, I also have MetalLB Load Balancer. That's part of the implementation too. Traffic ingress is part of the K3S, or can be. You can actually remove it. You don't have to have it, but I kept it in there. So as part of the K3S install, traffic is the default ingress, and will install unless you say that, unless you remove it from the installation. As far as the other gateway, right, that I installed Envoy Gateway. That's a prerequisite to Nutanix Enterprise AI. And then over to the left, right, you have the GPU operator, right, the DCGM exporter, right, so I can get metrics and those things, the NVIDIA device plugin, the NVIDIA drivers, right, which were already included, by the way. So when you install this, basically what you're doing is you're not including the driver install because the driver installation is already part of the Ubuntu operating system, the DGX OS install, right? So you don't have to install that. The other things that I installed, right, were were obviously, well, Core DNS is part of the K3S implementation, metric server, etc. But the other things I installed were Grafana. So basically the PGL stack, right, which is Prometheus, Grafana, and Loki. So I installed that, and I installed the K3S dashboard, right, to give me visibility into the cluster metrics. I installed Loki, and I've created a Loki dashboard. So these are all dashboards that were already provided through Grafana. I didn't do any customization or anything like that. And I can show you what that, actually, I don't know if I have it up here. Let me see if I can show you. Yeah. So, so here's Grafana, right? Here's the dashboard. You can see here I have my logs, right? For Loki. And this is the K3S dashboard that you can actually download and install. This one has Ceph cluster search. I don't use Ceph. That's why you see an NA here, but I can get all the other metrics, right, through the Kubernetes compute resources, DCGM. DCGM exporter I have not set up yet, so this is blank. So I haven't set up the scraping on that yet. But the GPU metrics I'm getting right now are all through Nutanix Enterprise AI infrastructure through the OpenTelemetry operator. Okay, so again, I have all of these things. So for someone who uses Kubernetes and wants to look at deeper visibility, observability, right? I definitely want to have Prometheus, Loki for logs. NAI doesn't come with a log server, so those logs are pushed to a syslog server, and then of course the visualization, the observability, right, through Grafana. So that's all been installed already. So that was kind of done before I did anything else. Made sure it was working, and then there were some other requirements that had to be installed, right? So Envoy, Kserve, right? You can see here over to the right the Kserve controller, right? So some of those things, and that's all documented in the NAI documentation. Okay, make sure those things are installed and configured the way they need to be installed. Now, I'm using NAI 2.6, which is the latest release. And so when you install Envoy, there are two ways to install it, right? There's the Unified Gateway enabled version, and then there's the standard version. So I'm using Unified Gateway. I'm going to demo that new feature. And so I installed Envoy to support Unified Gateway. And then you install the NAI core services, and you can see here up these here in the core services, right? The OAuth 2 proxy, the UI, ClickHouse, right, which is our analytics database, Redis, basically for cache, kind of a cache watchdog, right, for high availability. Postgres SQL, which is the database for NAI, those types of things, right? And then I installed basically the core, right? So there's operator services, right, which are ClickHouse and those types of things, and there are core services which are really focused on NAI, and that's like I said, the API, the model controller, NAI Labs, which I'll show you, the UI itself, etc. So all of this is installed on the non the D, not the Proxmox, the x86 K3S node, right? So that's the control plane. It's installed there. Okay. And then there's some things obviously installed on the Spark, right? The GPU operator, et cetera, has to be installed on the Spark because that's where the GPU is. And one of the things you're going to find is, and there's a gap, NVIDIA doesn't have an option right now to give you some GPU metrics because it's a unified memory model in the GB10. And so there are ways of kind of getting around that. I didn't implement those. Not yet. I'll probably look at those, but I'm still kind of waiting to see how NVIDIA is going to tackle that. They may not tackle it, right? Who knows? You can use NVIDIA SMI or GPU top, NV top, right, to get more GPU metrics. That's all something you can install locally. But again, this is Kubernetes. I don't want to do that. I want to have, visibility, right, observability into my observability tooling as well as NAI, right? That's the whole point of it. So that's kind of how it's set up. And so let's get into, before I get into NAI itself, let me just log into my storage stack. So again, this is not running anything Nutanix. Remember, NAI can run on any, Kubernetes platform, right? That has accelerated compute as long as I have, third-party storage that can tie into Kubernetes, which I've done, right? So let me just log into my NAS and show you here. So I do have NFS stood up, okay, and you can see these PVCs. So I have a dynamic NFS provisioner, right, and storage class created within Kubernetes, right? So if I go into Kubernetes, and I do get a C, right, you can see here I have two storage classes. I have NAI NFS storage. And by the way, I only use this to make it easy because when you install NAI, it defaults to NAI NFS storage for your read write many storage class. Okay, but you could change that in the Helm charts and the implementation if you wanted. But I just kept it like this. And this is basically a default NFS provisioner, right? That gives me dynamic creation of the NFS storage on my NAS. Okay, so when I created the storage class, right, it's pointing to my NAS. So if I do a K, actually, sorry, uh, right. So this is pointing right to my NAS, right, which is on the 110.200, and that volume K3S, that basically was the share I was showing. So if I go in here, right, it's basically volume. If I go to properties, volume K3S. So it's creating all of the dynamic NFS shares in here. Nutanix docs, I'll talk about this in a minute. I'm not going to focus on this right now because it's something that's actually not working and it has to do with fine tuning. It's one of the advancements in 2.6. We'll talk about that here in a little bit, but I want to talk about that more when I get it working. But this is pretty much the storage class and the NAS, the storage. Okay, what I have noticed is this is basically an all NVMe storage solution from Ugreen, and it's running NFS services, right? And it's only NFS 3, it doesn't support NFS 4, unfortunately. Okay. And so that's not officially supported because I think you have to have, if I recall, it has to be NFS 4. So that's not officially supported either, right? Matter of fact, everything I'm doing, I should have talked about that, is not supported. Okay. This is something that I did on my own, and with 2.6, it made it a lot easier. And by the way, there was another gentleman within Nutanix that actually worked on this, and I was playing around with what he did. But 2.6 actually brings the ability to not have to do a lot of different things like recompile stuff. One of the things I did have to do, and I didn't talk about that, going back to the diagram, is for OTel, right? For Open Telemetry, the version of OpenTelemetry that we provide does not support ARM. So I had to move to a more current version of OpenTelemetry that supports both x86 and ARM. So I had to upgrade that, and that was kind of the only. I'm trying to think. That was the only thing I had to do for ARM, other than I take that back. Other than like the GPU operator, I think that was already ARM compatible, if I recall. But going back, I know I had to go for the OTel. I had to upgrade or use a newer image for that supports both x86 and ARM, because ours, the one we provide, does not support ARM at all. Right. So now I get telemetry, right, from my GPU node, which I'll show you here in a little bit. So yep. So I have the storage classes. You saw that. And I'm also using the local path, right? So local path storage is the storage that's on locally, right, on the node itself, right? So the 4 TB that comes with DGX Spark, that 4 TB NVMe, that's what's using the block storage. All right. So for anything block, I'm using local path. Now, this is something that you wouldn't do in production, right? Remember, NAI is not a lab solution. It's not a workstation solution. So how I'm treating it, right, is not what it was intended for. It's intended for enterprise grade platform. Okay. So you wouldn't have a local path. You would never use local path in a production system anyway. You just wouldn't. It's too risky. It's too much security issues with that. Okay, so you can see here the kernel version up here. I didn't show you this. So obviously the kernel is a little bit different, right? Because NVIDIA provides DGX OS, which is based on Ubuntu. And I'm using just the Ubuntu cloud image, the latest Ubuntu cloud image for 2404.3 LTS from the Ubuntu website for the x86 node. Okay, and that was an image I created in Proxmox. Okay, so now that everything was up, right, I created a certificate. I patched the ingress with the certificate, right? And so now I'm logged in. You can see here I'm logged into Nutanix Enterprise AI. And this may look a little bit different for a lot of folks because you may have not seen 2.6 yet. 2.6 was like a massive. I don't know why we should be out there like screaming from the rooftops on this release. There was massive innovation in this release, right? I like it's a 2.6, but I feel like it's almost like a 3.0 release with what we brought in. Okay. Now some of it is tech preview, right? It's not for production yet, such as unified endpoints, right? That was early access in 2.5, non-GUI based. Now it's GUI based, right? Tech preview. The ability to add third-party providers, right? And so let me get into this because this is where a lot of the innovation is happening. If you go back and see my previous demos on previous releases, you can see all the other stuff around Nutanix Enterprise AI, like users, how we manage users, and how we do auth and audit events and all that stuff. Okay, but I really want to focus on a lot of the things that we're allowed to do here now, right? So with inference, you have the ability for unified endpoints, right? So this is tech preview, and what a unified endpoint does is allows you to create a unified endpoint of either multiple on-prem NAI solutions or environments, right? So say you have an endpoint that's running on one cluster and another endpoint running on another cluster. Maybe that other cluster has different GPU capability, et cetera. And you either load balance between the two or you do some sort of failover, right? Or you do some sort of token load balancing, right? Token-based load balancing, which I'll talk about in a minute. Okay. And so as we go in here and look at this unified endpoint I created, right? It's actually, if you look at the models, let me just make this bigger. Over to the right-hand side here, I'm using an on-prem solution and an OpenAI solution. So now I have the ability to route my AI inferencing endpoints, right, through a unified endpoint that can do, like I said, it can load, it could point to multiple models on-prem, it could point to a model on-prem and offsite, right, into a third party, like OpenAI or Anthropic or Azure or AWS Bedrock or any of those it supports, okay? Or you can do just external, right? Maybe you want to, or you can do external in different models. So maybe you want to have GPT-5 and OpenAI as your main, and you want to fall back to GPT-4 mini, right? From a token usage perspective, right? For cost control, or you want to fail back to a different provider altogether or fail back on-prem. You can do all of that. And so let's go through that and see what that looks like. So let's create a unified endpoint. We'll just call this demo unified endpoint. And you can choose between the API spec. Is it chat? Are you doing re-ranking or embeddings for RAG? What about image generation? So we support these different API specs. We'll just choose chat. And I can add a model here. So you can see here, I can provide a local model, right? Or I can provide a provider. So let's do a local model first. We'll just do the local model that's running in my NAI environment, running on DGX Spark, by the way. And now I can go here and I can add another model. So let's choose a provider model, OpenAI, and I'll choose GPT-4 Mini, right? And so now I have the ability to route my AI inferencing endpoints, right, to different models, different providers, etc. Now, that's one part of it. The second part of it is the power that this provides, right? So I can load balance between the two. So say I want to do, okay, I want to do, 75% in OpenAI and I want to do 25% in on-prem. So I have the ability to spread and balance the traffic, right? The incoming traffic for AI inference and model inference, right? Back through this load balance way. The other thing I can do is I can do fallback, excuse me. So I can say, okay, I want OpenAI to be the first order provider, right? And if something fails with communication, network, I want you to fall back to my on-prem model. Okay. And you can do that. Okay. That's another thing you can do. And you can select the API keys that have access, right? And these are internally managed API keys that are managed through NAI. And of course, you can obviously bring them into a key management system like Vault, something like that. But let's just go back to and choose FL01. I hit next, right? And now I can do rate limiting globally or per API key. So if I create this, right, I'm going to have basically a failback unified endpoint where all my traffic goes to GPT-4o Mini and OpenAI. And then if it fails, right, or there's a network issue, it'll automatically fail back to Llama 3.1 8B instruct. Okay. So if I hit create, and this is already created, and I have a failback order, and when I go back in here, I can do a rate limit. So this is one of the things that customers are really keen on, and they really like this. And by the way, this is very, very early, right? We're not even close to being done with the power of what this can provide. Okay. Security, all these access, all of these things we're going to talk about a little bit later, but let's just focus on what it can provide today. So I can do a global rate limit, right, across API keys, right? Maybe I say, okay, 30,000 tokens, or excuse me, 1,000 tokens per minute, right? Or I can do a per API key, right, rate limit. And what I can do is I can say, I can attach and keep track of a rate limit for right now, up to 50 API keys. But I can say, okay, if this endpoint reaches this rate limit, then go to the other end. Maybe I go locally and I'm not charged a per token cost because it's local, right? And that's the power of unified gateway from that perspective. Okay. Let me show you this just in action, right? So let's do the UE demo, and we're going to use the labs, right, to actually test this. So I'm going to go back to chat, and this is a integrated labs chat that you can do some testing with, some basic testing. And I'm going to use the UE demo, and I'm going to use my API key. Okay, and now if I type in here, tell me about NVIDIA. Sorry, who is NVIDIA? Okay, so I can already tell that this is hitting my OpenAI endpoint because it's very, very fast. Because of course OpenAI has, they have like, you know, Grace Blackwell GB300 platform on the back end. They have a ton of capacity, right? And I have a DGX Spark, and I told you that the DGX Spark is great with memory size, right? It's got a roughly an RTX 5070 Ti performance, or excuse me, configuration perspective from a GPU perspective, tensor cores, etc. But it's limited on the memory bandwidth. It's only like 270 or 280 uh, uh, gigabytes of throughput, right? That's not a lot, okay? And what we're looking for is we're looking for like 800, 900, 1,000, right? That's when you're talking about like RTX, RTX Pro 6000 Blackwell, etc. And that will speed up the code process, right? And so when I do inferencing on DGX Spark, it's not fast. Okay, now if I do an NVP4 small model, like that's been quantized down to NVIDIA's NVFP4, that can be fairly fast, right? But like a same large model on 128 gig of RAM with that limited memory bandwidth, GPU bandwidth, versus a real RTX 5070 Ti. I could, the RTX 5070 Ti will blow it away in performance from a memory bandwidth, the code phase, right, and the inference engine, right. So if I type this again, who is NVIDIA? Okay, you can see how much slower it is, and it's a different answer. So that basically went through. So this one went through the OpenAI endpoint, and this one went through the on-prem Llama endpoint. Okay, and the reason I know this is just based on the speed. But what I have set up for this inference endpoint, right, and the unified endpoints on UEE is 50% load balancing. All right, so if I edit this, right, you can see it's 50-50, right? So send, basically 1-1-1, go back and forth. Okay, so GPT-4o Mini was first, then it hit the Llama 3.1 8B instruct. So there's your load balancing. I can't really test fallback order because I'd have to kind of do some things with networking. Again, it's what applies here is okay. Everything to GPT Mini, right? In this case, right? Or on failback, go to my local, right? In case of a failure. So let me cancel that. You still get all of the metrics, right, from a token utilization perspective. You can see here the models. You can see here the the API keys that are associated with this endpoint. And these API keys, what you're going to give your AI developers to access, right, for the applications to access these endpoints. Now you can traditionally do local endpoints too. And by the way, the local endpoint, right, this Llama 318B instruct, right? This is GB again. You can see here the GB10. This is the active endpoint, but this active endpoint is actually integrated into the unified endpoint, right? Because I added a local and I added a provider endpoint. Here's where you add providers. You can see here I have my OpenAI provider, right? But I can go in here and I can add Anthropic, AWS Bedrock, Azure OpenAI, NAI, right, which is another endpoint, right? OpenAI, which is what I use for OpenAI for GPT. Okay, and you add providers and you add credentials, right? You have the platform credential, which basically is the API key for my account, right? This is the API key that OpenAI gives me for my account for OpenAI. All right. Now I want to go back into just local endpoints for a minute because there's some major things that have changed in here, which are very exciting. So when I create an endpoint, it gives me the ability now to use a VLLM sandbox. And by the way, this is the only way to get this working on DGX Spark. All right, unless you hard code. In 2.5, we had somebody in Nutanix, right? We had an awesome engineer consultant who actually did this in his lab with his DGX Spark, and he actually basically changed the image for VLM and hard coded it to an image that supports ARM and the GB10. Okay, out of the box, Nutanix Enterprise AI does not support GB10 GPU, right? Or excuse me, the unified GPU. Okay, because we're using a version of our VLM that doesn't support it. But with 2.6, we now have the ability to what's called the VLLM sandbox. And so when I create an endpoint, or I call this test, all right, we'll do this, we'll do this, we'll do acceleration GPU, GP10, I'll just do a key. Within the VLLM engine, right, you have this standard NAI version, this 0.13.0. That's the version that NAI ships with for VLLM, okay? But what I do is I import from a registry and I select the one that supports DGX Spark. And the one that supports DGX Spark is in this registry, and it's VLM 26.01-PY3. That's the most updated VLM NVIDIA based VLM engine that will support DGX Spark. I can't stand up, right? If I use the native NAI VLM, it will fail. The endpoint creation will fail. So I have to use this. And you can import from a community VLM registry, right, from Docker as an example, or you can import from another registry. I import right from NVR, the NVIDIA registry. Okay. The other thing it does is it provides custom arguments. Okay. So I love this too, because now I can do a whole bunch of different things. I can set my limitations, my max on GPU memory, right? So I can use more of the GB10. I can, I can trust code execution. I can do max tokens support, right? I can choose my D type, right, to auto, right, whatever the native D type is with the model I want to use, right? Whether that's BF16 or FP8 or FP4 or NVFP4, right? If I do D type auto, it'll use the model's auto um, what's provided, right? What we're delivering with the model, right? If it's NVFP4, it'll deliver NVFP4. Now you have to have GPUs that support that. The GB10, excuse me, supports NVIDIA's NVFP4, which I think is pretty phenomenal, by the way. I mean, FP4 quantization, people be like, that's going to be horrible. But NVIDIA has done a lot of fine tuning on these models to make them a lot more accurate than native FP4. Okay. So when you download an NVFP4 model, it's much more accurate versus the FP4 model. And it's very fast, right? So again, I can add arguments in here, and I have arguments already set up. The other thing they've added in Tech Preview is KV cache aware routing, right? So if I have multiple GPUs and I'm going through an inference and I'm storing the cache of the context, right, or the system prompt, and both, excuse me, and the conversation, right, that I'm having or whatever in GPU memory, I want to make sure it's serviced, right, through the GPU that is storing that memory, right? Not go to another GPU, right? And then that context is in another different GPU that provides latency, right? So we want to make sure that we have context, or excuse me, KV cache aware routing. Okay, that's one of the things that was enabled in Tech Preview as well. And then, of course, you can come in here, create the number of instances, how many vCPUs, et cetera, hit next, and that creates the endpoint. And so this is what I love about, what 2.6 brings is really this ability to bring in some more customization, to test different engine types, test different arguments as it makes sense, right? To be more granular in how we want to set up our inferencing, our model endpoints. Okay. So I went over inferencing, right? So basically unified endpoints, local endpoints, excuse me. And you can test this. The same testing applies, right? You can see here it works, etc. And I'm getting all of the data, right? The telemetry data back, including, right, the logging data, the usage, the performance data, right? Time to first token, latency, etc. I'm getting all of that, even though I'm running on a third-party Kubernetes platform. I'm only running the only solution I'm running that's Nutanix is Nutanix Enterprise AI. That's it. Everything else is third party, right? K3s, the Proxmox, right? The storage is my NAS, right? This is NAI running, right, on third-party platforms, proving that you have all these different types of consumption models. And we're providing value where it makes sense, meeting you where the customer is, right? That's what the whole point is. The other thing I've done too is one of the things that was missing was the infrastructure metrics, because um, remember I said the open telemetry for ARM that Nutanix delivers in the packaging, the image doesn't support ARM. And so I had to upgrade the OTel, right, operator, et cetera, to support ARM, to support the GB10. And now I have all of my metrics, right, through cube state metrics, right, et cetera, right, for my cluster, right, for my nodes, and for the Spark, right? My accelerated utilization. Again, the memory usage will not be there. It goes back to that a known issue, that the fact that it's unified memory. GB10 is a unified platform, Grace Blackwell, and it's using unified memory. And so NVIDIA doesn't have the solution in place to kind of decouple the unified memory for GPU, right, frame buffer, versus for system memory, right? So, or application memory. So that's why this is missing. Now you do get like total memory usage, but you can't really decipher between the two, right? What's using GPU frame buffer and what's using application system memory, right? It's just a total memory utilization. What else here? Oh, so they added some things in labs I think is pretty cool and unique. So you can add either unified endpoints or single endpoint, right? Doesn't have to be a unified endpoint, could just be a local endpoint. But you can also add a safeguard endpoint for content security. And so this is great actually. So the ability to add safeguard models, right, hosted by NAI, and being able to safeguard the content, right, of which you're trying to do inferencing. So if you're doing a chat, an end user can't ask to say, hey, how do I do something illegal or unethical or something against your ethical guidelines, et cetera, in the company, right? Or your compliance, right? And so you can fine tune like these Nemo Guard models, the content safety models, right? With your regulatory compliance, ethics, right, et cetera, to make sure your AI solution is ethical, meets regulatory requirements, et cetera. The talk to my data has also been changed, so you can actually do a talk to your data. So you can use your LLM, add an embedding endpoint, a re-ranker endpoint, select your documents, but you can do two more things. You can actually add the safeguard, right? Which is what I talked about just a second ago. But you can also do object detection. And so what object detection is imagine you have media, right, like a video or picture, and you want to be able to chat with your video or your picture, right? So where is this? Where would you see this in a use case? So imagine you're a manufacturer and you have real-time video in your warehouse, and you have safety guidelines in the warehouse. And so you have real-time video. You want to alert on that video if you see a safety or a possible safety concern. Maybe your worker's not wearing a hard hat in a specific area that they're supposed to wear a hard hat. Maybe they don't have a harness when they're climbing a ladder, right? Other use cases are for accidents, right? So maybe I have a camera at a traffic stop and I want to alert on accidents, and I want to be able to get the